What? By, by parts. Partial fraction is over. Na? Today we will do integration by parts. Now, if you can remember, I told you before that like in differentiation, in integration also we can split addition and subtraction. If there is any constant, we can take the constant out of the integration or differentiation, isn't it? But like in differentiation, we had your separate formula for multiplication or division of any two functions, isn't it? For multiplication, we had in division the product rule, and for multiplication in differentiation, we had the product rule, and for division, we had the quotient rule. So what will happen in integration if you have multiplication or division of two functions? We will apply this rule. What is the rule? By parts. Whether multiplication or division, we will put it in this form and we will apply the rule of by parts. So what is the rule of integration by parts? Let us see. Say for example, we are taking once again our good old friend x, with respect to which we are integrating some function of x. Some function of x which we call our what? What do we call the function that we integrate? What do you call, Venkatesh? What do we integrate? Yeah. Somebody said it. Loudly. Integrand, isn't it? So suppose our function of x, which is the integrand, that can be written as multiplication of two composite functions. Say your integrand fx may look like x into sin x. See, one function is x, another is sin x. One is x, another is sin x. Or it can look like, say, maybe x into log x or x square into log x, anything like that. Multiplication of two functions, isn't it? So in general, let us take fx equal to, say, multiplication of two functions u and v. U and v. Do you remember in differentiation we took u and v? uv rule, u by v rule, those were product and quotient rule. So integration also in by parts will take function is looking like, say what? U into v. What are u and v? They are any functions of the variable x. They can be polynomial like x, x square, x cube, 3x plus 1, anything. Or they can be logarithm, log x, sin x, trigonometry, inverse trigonometry, sin inverse, cos inverse, tan inverse, exponential, e power x, anything. Okay? Then your integration by parts will be given by, hold your breath, this formula. Let us take u is the first function, v is the second function. Then it will be first function into integration of second function minus integration of differentiation of first function into integration of second function whole integration. Happy? Not happy? Long formula. Meena? Formula is looking long. No? Easy? What happened? Arul? Long, huh? Not so long. If you keep practicing questions, it will become familiar to you. If you keep on practicing questions, it will become familiar to you. So, if we say u is the first function, v is the second function, then the integration of u into v dx will be given by the formula u into integration v dx minus integration of this whole thing, where we do differentiation of u into integration of v and then we again integrate. And then we again, what? Harshita? Then we again integrate. So, why am I calling u the first function, v is the second function? Because it matters which one you take the first function and which one you take the second function. Why does it matter? Because see, very simple example. In the first term, u is sitting alone, but v is undergoing integration. In this portion also, v is undergoing integration, but u is undergoing differentiation. The two functions u and v, they are undergoing separate things. Yes or no? u is undergoing differentiation, but v is undergoing integration. Yes or no? And as we have done integration so far, we have done substitution, we have done partial fraction. In substitution also we have done various types of methods here and there using trigonometric identities, this and that, and we have noticed something, that every function is not easily integrable, isn't it? Every function is not easily integrable. That is why it matters which one undergoes what operation. The first function u undergoes differentiation, whereas the second one v undergoes integration. That is why it matters. That is why it will matter whenever you will be given the product or the combination of two such functions, which one you should choose as the first function u and which one you should choose as the second function v. And how to choose it? How to choose it? Based on a rule, isn't it? Based on a